Our goal now is to take a function f of x and start with something like his graph here, right there, that's f of x. Now I don't know what the equation is, but I don't need it. I can start with the graph, and I want to apply some transformations to this function and get some new graphs, like these two over here and a couple more down below. So the first thing I'm going to do is I'm going to take f of x and I'm going to pick out some good representative points. Some points that will help me see the shape. Enough points that if I played connect the dots, I'd know what the shape is. So as I go through this, I see negative 8, 5 is a pretty nice one. I see negative 3, 5 as a pretty nice one. 0, 0 is a great one. And 1, 5. That's enough points so I can get a good idea of what this graph looks like. I'm going to take those, and those are the points I'm going to move all around, left, right, up, down, stretch, shrink, and flip, to get my new graphs. So if I come over here, scroll up just a little, I come over to this one, first one, f of x plus 2 minus 5. I remember previously I looked at, well, that means it's down 5, and this means left 2. So I pick up this whole graph, the whole green one, and just move him left 2, down 5, and set him back down. Which would be easy enough here. If you imagine it, left 2, down 5, that point's going to end up there. And I just do that same thing with everyone else. But I want to get a more general way of doing this that's going to help me more in the future. So what I'm going to do is I'm going to say, hey, any x comma y, any point is moved in the following way. I have x, and if I'm going left 2, that's going to be an x minus 2. You have to take 2 away from the x's. And all the y's are y minus 5, because we have to move down 5 on all the y's. So now what I do is just take all the green points, send them through what I like to call this filter right here that I just developed, and then see where the new graph ends up. So I'm going to come down. This does involve a little bit of extra writing. So I'm going to say, hey, okay, I have negative 8, 5. I'm going to relist all of my points. Negative 3, 5, 0, 0, and 1, 5. And let's run them through that filter. So for example, in the first one, if I take negative 8 and plug them in there, I'm going to end up getting a negative 10. Take 5 and plug them in there, I'm going to end up getting a 0. So the first point is at negative 10, 0. Which, if you remember, when we moved him, that's where he ended up. Now I'm just going to apply this to all the other points. Negative 3, 5 is going to become negative 5, comma 0. So he's right there. 0, 0, run through that filter, is going to become negative 2, negative 5. Negative 2, negative 5. And lastly, 1, 5, run through the filter, is going to become negative 1, 0. Negative 1, 0. So if I go through, I can see where my shape is. So I connect the dots, and I get the same shape. It's just been moved left 2, down 5. So there's my transformation of that function. Now I can take any of those transformations we talked about and apply them. So if I look at my second example here, I'm going to again go back to f of x and start with him and say, okay, this one has been moved down 2, because that's what that 2 with the negative at the right does. And I have a stretch, remember it's a vertical stretch, of 2. So I'm going to set up my filter. If you notice, the x's right here, they don't change. They stay exactly the same. So x becomes x, and y becomes, well, there's a 2 with multiplication and a minus 2. So order of operations, if I can get rid of that negative because there's no negative, order of operations says it's 2y minus 2. Multiplication first, then subtraction. So I come back down, go back and pick up all of my green points again, negative 8, 5, negative 3, 5. And I'm going to take all of these and run them through that filter, just like I did before. So he's going to become negative 8, comma 8. We're plugging the 5 in right there for that y value. This guy is going to become negative 3, comma 8. 0, 0 becomes 0, comma negative 2. And 1, 5 is going to become let's see, 1, comma, 8. So graph all these, negative 8, 8 is going to be up there. Negative 3, 8 is up here. I can start to see what my shape's going to look like. 0, negative 2, and 1, 8. So I have this guy here. I missed on this point a little bit. Let me get rid of him, draw him a little bit better. There we go. So it comes across, goes way down, and then way back up. And that's what my graph looks like. Something to notice from the 2, that's the stretch factor. To understand that a little bit better, let me get orange. If I come through and look at my height, like from top to bottom here on this graph, my height was 5. And as soon as I apply that extra 2 out there, I'm doubling the height. So if you come over here and check, the height of this new guy is 10, which makes sense. He should have doubled in height because of the stretch. So that's what that extra 2 times out front is going to do to my graph. We have 2 more examples toward the bottom, and I slightly cheated on these because I went ahead and put all my ordered pairs there already just to speed up my process slightly. So if I look at the first one, I have a lot of things going on. That is, let me get black, there we go. That's up 3 and left 2 and a stretch, and I have a reflection. And my reflection, since it's outside, is going to be upside down. And again, when I write out my filter, that's going to go ahead and take care of that for me, just so I know what the shape should look like here. So for my filter, it looks like the x's, since they're left 2, is going to be a minus 2. Remember, we're always taking that opposite of the inside. And the y's are going to be negative 2y plus 3. I multiply by negative 2 first because of order of operations. So I have my filter, and go ahead and start running all these points right here through my filter. So I'm going to get negative 10, comma, negative 7. I'm plugging in the x and the y right there, up here, into my transformed point. This is going to become negative 5, comma, negative 7. I'm going to get negative 2, comma, 3. And lastly, negative 1, comma, negative 7. So negative 10, negative 7 is going to be there. Negative 5, negative 7 is there. Negative 2, 3 is, oh, one more up. Let me get rid of that. Negative 2, 3, there we go. And negative 1, negative 7 is there. So my shape, this is where some people have a little more difficulty. Let me scroll back up quick. If I flip this upside down, he's going to go up, down, and over. Just kind of, that's what I'm thinking in terms of what upside down would look like. So see if that fits here. It does. I go over, he goes up, and he comes back down. So it's reflected upside down. I can see that. It's stretched by 2 if you look at your total height. Total height here again is going to be 10, so I have that stretched by 2. And I've been moved left 2 and up 3. Looking at my last one that I need to transform myself. Again, pretty straightforward. Up 3, and now I have a reflection, and it's going to be left, right, not up, down. So I go through and write my filter. My filter is going to be just negative x, because you have a negative x inside. It's not moved left or right at all. It's just multiplied by that negative, and y plus 3 is the other part of my filter. So if I come down and send all of my points through that filter, go back just a little bit so I can see it. There we go. This is going to become positive 8, comma, 8. Then we're going to have 3, comma, 8. I'm going to have 0, comma, 3. And lastly, negative 1, comma, 8. So I can start to graph my points. And I will see, once I get these all on here, that my graph is in fact going to be flipped the opposite direction, left, right. Because now the longer tail end's on the right instead of the way it was before, and it comes back up. So it's been flipped left, right, or it's been flipped over the y-axis. So those are all my examples of going through and actually transforming the function. But in this last one here, I have a transformed function, and I want to go ahead and write what the transformations were. So what I'm going to do is key in on the point 0, 0. Here's the bottom of that v. So 0, 0 has been moved, and in this case it's been moved left 1, down 3. So if I go to put that into my function, left 1 is going to be plus 1, and down 3 will give you a minus 3 out to the right-hand side. And now I notice that the shape has also been flipped upside down, and to be flipped upside down like this guy was over here, I had that negative out front. So I'm going to put that negative out front. And the last thing I need to figure out here is, do I have a stretch or a shrink? So if I look at that total height, and the total height here is 5, which is the height of the original, so there is no stretch or shrink to my function. If that was 10, I'd have to put a 2 in here, or if it was something like 15, I'd have to put a 3, but since that is still a 5 in terms of the total height, I don't have to put anything. So that's my transformed function. And with the last couple minutes we have here, just down at the bottom, looking at these, I'm taking a function r of x, and I'm applying some transformations. So here I see 1, 2, 3 transformations to apply. So if I go to write this, the vertical stretch gives me a 3 out front. And then I have r of, so I'm done with him. Horizontal shift right here, go inside. Right 6 would be x minus 6. You have to take the opposite. And vertical shift up 3 is a positive 3 up there. So there's my function r of x with those transformations. Looking at b very quickly, I've got 2 transformations. I have a reflection, which means a negative somewhere, and a shrink. So I put the 2/3 out front because shrinks go out front. I remember to write my function r, and then the negative goes inside because if I'm reflecting over the y-axis, I'm flipping left-right. So that's why the negative is chilling in front for that. Right in front of that x there, not the whole way out in front of the 2/3. So those are just taking and going backwards, writing the functions given the transformations. So the key to doing any sort of graphing of transformations is find that filter and then run all the points through it that you need to see the shape of the graph.